Good day, good day. This is Elton from Maths and Science series. We are back again. Today we'll be balancing chemical reactions or chemical equations. But before we can do that, let's just remind each other about what I've written here. So we have something known as a chemical equation or a chemical reaction. Now, here we have W that is summed with the X. So these are known as reactants. Then we have Y, which is summed with that Z. So these ones here, where the arrowhead is pointing at, we know them as, or they are known as being the product. Now, what does this arrow symbolize, or what is it telling us? It tells us that where the arrowhead is pointing at, those things that are on the right there, they are known as products. So we cannot have the products if there are no reactants that have reacted. Now, in other words, this tells us that for us to have the product, there must be reactants which are added. For an example, let me say I have 1 plus 1, then the answer is 2. So 1 and 1, they are reactants, then they reacted to give us the product which is 2. I don't know if you understand that. But the most, or another example which I can use, I know you guys, you like eating, you like food a lot. Now, for an example, let me say I have, maize meal plus water. They react to produce or to give us pap, right? For us to have the pap, what we must have as the reactants, it is the maize meal and the water. So we cannot have pap if we didn't react, or if we didn't add water with what? With the maize meal. I hope you understand this. So in other words, reactants are used. Why? Because we use them to form the product. So they are used up. Then the products, since the reactants are used to form these ones are formed. So this is very important. This is very important. Make sure that you are following, because what we're going to do now, as we're going to be balancing the chemical equations, what I'm going to explain here is very important. Now, we have things which are known as stoichiometric ratios or coefficients. Now, here the coefficient of x squared, it is 2, right? A coefficient, it is a number before a variable. That's a coefficient. Now, here it means that when I have an x like that, it means that the coefficient of x is 1. So even here, the coefficient of z is 1, the coefficient of y is 1, and the coefficient of x is 1. Also, the coefficient of w is 1. I hope you are following. So it is very important for you to know these things. But now if I have 2w, it means that the coefficient or the stoichiometric ratio of w is what? Is 2. And we have something again known as a subscript. A subscript. So these two, O2, the 2, it is called a subscript. That 2 tells us how many times is the oxygen or is the O repeated. As you know from exponents, those who are doing mathematics, you are all doing mathematics, I suppose. Now, x squared. This 2 tells us it is an exponent, tells us the times that the x or the base is being repeated. So even the subscripts here, we have the subscripts as O2. The 2 here, it is called the subscript. Why? Because it symbolizes, it represents the times that the O is repeated, or how many times the O is repeated. So here, balancing the equations, it is very important for you to know the stoichiometric coefficients as well as the subscripts. Basically, when you balance the chemical reactions or chemical equations, you need to make the subscripts on the reactants to be equal to the subscripts of the product. This is our first example. You are given H2O2 that reacted then to produce H2O plus O2. Remember, I told you that where the arrow is pointing at, those are the products. So they're saying that you have to, or you must balance this chemical equation. It is very important to know how to balance the equation, because in stoichiometry, for you to determine the excess, or for you to determine which reactant is the limiting reactant, it is very important for you to do it, to know how to do it, to balance the chemical equation, or to solve to determine the maximum mass. If you are in grade 11, it is very important for you to know how to balance the chemical reaction. Now, as I told you that these are known as subscripts, it means here the subscript of O is 1, because they didn't specify, they didn't write it, so it is not safe. So basically, when you balance the chemical reactions or chemical equations, you need to make the subscripts of the reactant to be equal to the subscripts of the products. Now let's check then. Here, actually, you do what you need to compare. You are proving. Now, on the reactants, we have H2. It means that we have 2 hydrogen atoms. Then here we have 2 hydrogen atoms. So we are good. O2, we need to compare it with the oxygen on the product. Now we have on the reactant part we have 2 oxygen atoms, but here we have, since I told you that here we have 1 subscript, it means that we combine this one with that 2. It means that we have 3 oxygen atoms. Then therefore this chemical reaction is not balanced, because we have H2, we have H2, we have O2, but on the product, or on the right hand side, on the product part, we have what? 3 oxygen atoms. Therefore, we have to make sure that the subscripts are equal. The subscripts of the reactants are equal to the subscripts of the products. So what is it that we're going to do? We need to make, we need to make this side to have how many subscripts? We need to make it to have 3 subscripts, as we have 3 subscripts on that right hand side. But how are we going to do that? Now, the first thing that we can do, let's put what? The 2 here, so that we can have 2 oxygen atoms. But now, what is it that we are having? We have this times the subscripts of H, we have 4, right? Then this times the subscripts of O, we have 2, right? Now, it means that on the right hand side, we have how many oxygens? We have 4 oxygens. Since here it is 2 times 1, we have O2, plus that 2, we have 4 oxygen atoms, right? Then the hydrogen atoms, we have 2 times 2, which is H4. So we need to make those things we need to make whatever that we are having on the product part to be equal with what we are having on the reactant part. Now we have H2 here. For us to have H4, what is that we have to do? We need to multiply, or we need to put the coefficient, which is 2. Therefore, now let's check if this thing is balanced or not. Now, this times this, we have H4, but even here we also have H4. Then this times this, we have O4. Then here 2 times 1, it is 2, plus that 2, it is 4. Therefore this chemical reaction or this chemical equation, it is balanced. So the most important thing, you use coefficients to balance the chemical reaction. Let us do the second example to see if you guys really understood this. Let's do the third one. Let me say we have 6 lithium N2 to produce 2 Li, 2, let me use the same ink, 2 Li 3N. Then they say balance it. Now let's check there. We have 6 Li. 2 times this, we have 6 Li. We have N2. 2 times that one there, we have N2. Therefore this one, it is balanced, because if you can use that method, this times Li, it is Li6 plus N2, this times that, Li6, this times the one there, it's N2. Therefore we have Li6, Li6, N2, N2. So this one is balanced. So your teacher can write down a chemical equation or reaction. Then they say, is this equation balanced or unbalanced? So you need to know how to check if an equation is balanced or not. Alright, let me say we have C2H6 plus O2, then we have CO2 plus H2O. Just pause your video, then you watch, pause the video, then you do this on your own, then you will just continue with it to see if you got it or not. All right, now here we have C2, we have C1 actually, so it is not balanced, right? We have H6, we have H2, it's not balanced. We have O2, we have 1 here, and we have these 2, so 2 plus 1 is 3, therefore it's not balanced. Now C2, C1, so for us to have C2 on both sides, we need to put what? The 2 here. Now we have C2 and C2. H, we have H6, here we have H2. So for us to have H6, we need to multiply 2 with the number that will give us 6, which is 3. Therefore we have H6 and we have H6. O2, we have O2 here. Then how many oxygen atoms do we have on our product side? 2 times 2, it is 4. Therefore we have O4 on this side. Then here it's O3. We have 3 here. Therefore 4 plus 3, we have 7, right? Now we need to do what? We need to get a number that we can multiply with these 2 to get this 7. So we don't have it, right? Now what you have to do, just take that 7, then you divide it by 2. You will have 3.5, 7 over 2, right? Now you are not done proving this. Why am I saying you are not done? It is that when you balance chemical reaction, we don't want fractions or decimals. Maybe someone will just say 7 over 2 equals to 3.5, then you put 3.5 here. Even if what you're doing is right, but we are not supposed to put our coefficients as fractions or decimals when we are proving. So what is that we're going to do as I place that 7 over 2 in front of the oxygen atom, or as the coefficient of oxygen atom? Now what you have to do, you take that 2, which you divided with this one. You multiply every or all the coefficients here on this equation. So here, since we have 1, I will say 1 times 2. We have what? We'll have 2C2H6 plus 7 over 2 times 2, which is it's like 7 over 2 times 2. This will cancel that. We'll be left with 7, right? 702. Then 2 times 2, since it is the lowest common denominator. Then this times that, it's 4CO2 plus this times that, it is 6H2O. Now let's prove if it is balanced. We have C4. We are just proving C4. We have H12. We have O14. We have C4. We have O8. We have H12. Then 6 times 1 here, we have O6. This is O6. Then let's prove. We have C4 here. We have C4. We have H12. We have H12. Now here we have O14. Then here we have, this is 8. 8 plus 6. It's 14. Therefore this thing is proved. Or it is balanced. I wanted to say it is balanced. So the most important thing, when you have the total coefficients or the total subscripts of the product or the reactants, then that total one, since we got 7, we don't have any number that is not in decimal that we can multiply with what? With 2 to get that 7. So what I did, I said 7 over 2. Let me say you got 9. You are going to do that 9 over 2, then you take that 2, you multiply all the coefficients, and after that you will have something like that. Then you prove it the way I showed you on how to prove it. All right, let's do the next one. Then I'll give you 1, then you just send your answer. Actually, you don't have to send your answer. You see, you just do it. You just actually you are preparing yourself here. Then you continue the video seeing that you got it or you did it. And by the way, these are combustion reactions in the excess of oxygen. All right. Let me say we have petrol, C8H18 plus oxygen atom, CO2 plus H2O. Then they say balance the equation. This is, we have C8 here. We have only 1 carbon atom. Therefore, for us to have 8 carbon atoms, we need to do what? We need to put the coefficient or stoichiometric ratio. We don't put subscripts. Now we have H18 here. Then there we have 2 hydrogen atoms. It means that for us to have 18 hydrogen atoms, we need to multiply these 2 with a number that when we multiply it with 2, it will give us 18, which is 9. We are done. Here we have 2 oxygen atoms. Then what about here? We have these 8 times 2. We have 16, right? So we have 16. Then plus 9 times 1. It is 9, right? Therefore we have 25 oxygen atoms on the product side. There's no number which we can multiply with these 2 to have 25. So we'll do what I did on the previous example. So you can just pause it, or you go back to that other one, you watch it until you understand it. That is when you're going to understand this one. Then I'm going to take this 25 and divide it by 2. Because when the number that I can get to multiply it with 2 to get 25, it's 12.5, right? And I told you that we're not supposed to write decimals as coefficients or fractions. You don't leave it like this. Therefore, you take the 2, the one that you divide it with, you multiply all of these stoichiometric ratios or the coefficients, or whatever that you are calling them. So 2 times 1 there, we'll be having 2C8H18 plus 25 over 2 times 2, we will have 25O2. 8 times the 2 will have 16CO2. 9 times that 2 will have 18H2O. Let's prove it if we balanced it accordingly or correct. So we have C16, right? Here we have, is it A36 plus here, which is O50. Here we'll be having C16 and O32. Then plus, I don't know if you understand how I got this 32. 16 times 2, I got 32. This times that, H36, then O18. Let's check then if we are having the subscripts on the left that are equal to the subscripts on the right. We have C16, C16, H36, H36, O50, then add the 32 and the 18. You will get what? 18, you have 10 here, you have 4 and 5, it's 50. Therefore, this chemical equation, it is balanced. Remember, don't leave it like this. You are not allowed to do it, to leave it in or to have a stoichiometric ratio or a coefficient that is a fraction. You take that denominator that you've divided the 25 with, then you multiply all the stoichiometric ratios or the coefficients or the mole ratio, then you multiply all the coefficients with that 2, so that you can have your answer that is wanted, because we don't want fractions as stoichiometric ratios. Let me say we have C4H10 plus O2. They react to give us oxygen plus H2O. Then they say balance it. Now, the most important thing for you to know first before you can balance, check if it is balanced or not. They can give you a balanced equation. Then your teacher asks, is this equation balanced or not? So C4, we have C1 there, so it's not balanced. Now for us to have C4 here, to match it with the C4 on the reactant, we need to put the 4 here to make them to be equal. Now the carbon atoms are balanced. We have H10 here. Here we have H2. Which number can we multiply with these two to give us 10, which is 5? Hydrogen atoms are also balanced. Now, we have O2 here on the reactant. How many oxygen atoms do we have on our product? So we have O2, 4 times 2, it is O8, or it is 8, plus 5 times the 1 here, it is 5. We have what? 13. Which number can we multiply with 2 to have 13 so that we can balance the oxygen atoms on the product side with the oxygen atoms on the reactant side. We don't have that one because we're going to have a decimal. So it's 7, is it 6.5? It's 6.5. So we're going to take the 13, we divide it by 2. I hope now you are understanding this. You take that denominator, you multiply with all the stoichiometric ratios of the equations. Of the equation. Now, since it is 1 here, we say 1 times that 2. We have 2C4H10 plus 13 over 2 times 2. It is 13O2. Then 4 times 2, it is 8CO2. 5 times 2, it is 10H2O. Then let's use that other method to prove if it's really balanced. This and this, it's C8. This and that, it's H20. This and this, O26. This and that, this and this is C8. This and that, it's O16 plus this and this, it's H20, 10 and 1 there, it's O10. Then C8, C8, H20, H20, O26. Then here we have O16 plus O10, then 10 plus 16 is 26. Therefore, it is balanced. Don't present this one in your answer sheet. You are just using this to do what? To prove that this equation, it is balanced. We have Na2CO3 plus HCl to produce sodium chloride, or NaCl plus H2O plus carbon dioxide. So let's prove if it's balanced or not. Then we balance it if it's not balanced. Na2, Na, so it's not balanced. Therefore, we'll put what coefficients to balance it. So this is Na2. We have Na1 there. So for us to balance them, I need to put 2 there so that we can have Na2, Na2, right? We have 1 carbon and we have 1 carbon. Then we have O3. We have 1 here and 2. We have O3. We have H1 here, or 1 hydrogen atom. Here we have 2 hydrogen atoms. So for us to make sure that they are equal, I have to put 2 there so that they can be balanced. The hydrogen atoms can be balanced. We have 2 HCl here. Even here we have 2 we have 2 Cl. Even here we have 2 Cl. Now let's check if this thing of us it is balanced or not. Na2, Na2. C or one carbon atom, 1 carbon atom. O3. We have 1 there plus this 2, it's O3. 2 hydrogen atoms, 2 hydrogen atoms. 2 Cl or 2 chlorine atoms, 2 chlorine atoms. Therefore, it is balanced. Or you can just use this thing and A2CO3 if you are not sure, which is H2 here, Cl2, and A2Cl2 plus H2O plus CO2, and A2 and A2, C1 and C1 there, O3, and we have 1 plus these 2, we have 3. So these ones are balanced. H2, H2, Cl2, Cl2. So you balanced it. Then you do what? You remove or you erase this thing that you used to do what? To balance using. So that was how you were supposed to balance that chemical equation. we have Na2SO4, right? Plus the calcium carbonate plus carbon, then they give us Na2CO3 plus CO2 plus CaS. Now let's prove, actually the first thing we must do is to prove if it is balanced or unbalanced. N2, N2. We have one S and we have one S there, sulfur. O4, and this subscript plus that we have 7 oxygen atoms. Then here 3 plus 2, we have 5 oxygen atoms on the product side. So it is not balanced. So for us to balance it, okay, let's just write everything that we are given. We have Na2. We have sulfur, one sulfur atom and one sulfur atom. We have 7 oxygen atoms. 4 plus 3, it's 7. 3 plus 2, it's 5. Alright, it's not balanced. We have 1 calcium atom, 1 calcium atom. How about the carbon atoms? We have 1, 2, and here we have 1, and here we have 2. So what is it that we're going to do? Or we must make sure that the oxygen atoms are balanced. Since we have 7 here, here we have 5. So let's try to balance it. Now, let me see if I can put the 2 here to see if it won't lead us to where we must be. Now, we have 2, actually we have 2 carbon atoms plus this one we have 3. Then here 1 carbon atom plus that 1 carbon atom, we have 2. Therefore, for us to have 3, let me put another 2 there. Then we have 2 carbon atom plus that 1 carbon atom, we have 3 carbon atom. 2 carbon atom plus 1 carbon atom, we have 3 carbon atoms. Now, Na2, Na2. 1 sulfur, 1 sulfur. O4 plus this, it's O, is it O? Yes, it's O7. Then O3 plus this times that, it's 4. Therefore, 4 plus 3, it's O7. 1 calcium atom, 1 calcium atom. This we discussed about it, okay? 1 carbon atom plus 2 carbon atoms, we have 3 carbon atoms. 1 carbon atom plus 2 carbon atoms, we have 3 carbon atoms. Yeah, so it's balanced. Let's check it. It's Na2SO4 plus CaCO3 plus C2Na2CO3 plus C2O4 plus CaS. This times that I got O4. Therefore Na2, Na2, S, S. O4 plus O3, it's O7. So we have O7. Now here, O3 plus O4, we are having O7. Ca, Ca. How about the C carbon atoms? We have 1 plus 2, it is 3. So we have 3 carbon atoms. Here we have 1 carbon atom plus 2 carbon atoms. We have 3 carbon atoms. Therefore, it is balanced. It is balanced. So just let me give you this one. Actually, we have reached the end of the lesson. Now, do this one. It is P4O10 plus the water, which will react to give us H3PO4. H3PO4. So do this one on your own, just to exercise just to do it, to see if you understood what we were doing all along. All right, and please guys, do not forget to subscribe, like, share and comment.